All right, so today is a continuation of section 10.4, compound probability. So today we're going to talk about the complements of events. So for event A, the complement is A with a bar over it, and they literally just say A bar. And so the complement is the events that are not in A. So suppose event A is I go to Pinecrest Lake for the day. The events that are not in A is I don't go to Pinecrest Lake for the day. All right? Suppose that I only go to Pinecrest if it's a weekend. What's the probability I'm going to go to Pinecrest?
2/7.
2/7. What's the probability I'm not going to go to Pinecrest? 5/7. So when I have an event and its complement, they should add up to 7 out of 7 or
Total.
1, right? It's always going to add up to 1. So to find the probability of a complement, you just take 1 minus the probability of the event happening. So the probability of A bar is 1 minus the probability of A. All right, so if I roll 2 6-sided dice, there are 36 possible outcomes. And we know that because I've got 2 dice that I'm rolling. They each have 6 sides. So 6 times 6, there's 36 possible outcomes. So I want to find the probability that the sum of the dice is not equal to 6. And there's a lot of ways that I could roll dice and get it not equal to 6. There's a whole lot less ways when it's actually equal to 6. So instead of figuring out all the ways it could be not 6, it's easier if I just figure out how many ways it is equal to 6. So the sum that it's not 6 is going to equal 1 minus the probability that the sum equals 6. So I've got 2 dice that I'm rolling, and so I'm going to make myself a little table of what possible ways I could get 6. And you've got 2 separate dice, so you have to think about what each one is going to roll. So what's one way that I could get the sum to equal 6 with 2 dice? 3 and a 3. That's the most obvious one. Okay, what's another one? 5 and 1. So I might have a 5 on the first die and a 1 on the second die, but I also could have a 1 on the first die and a 5 on the second die. Okay? So you have to think about both possibilities. And then what's another way to get 6? 4 and 2. Yeah. So 4 and 2 or 2 and 4. Are there any other ways? 6 and 0 is not going to work because there isn't a side on a dice that has 0. Okay, but that's okay. Everybody, it's like one of those things, unless you actually have the dice in front of you, you just may not even think about that. So it's okay. You're not the first one to ask that today. Okay, so that means that the probability that the sum is not 6 is going to be 1 minus 5 out of 36, or 31 out of 36. So I would have had 31 things in my table if I had made the table of all the ways that it would not equal 6. And that would take a whole lot longer than just making a table with 5 things, right? So that's going to equal the probability that the sum does not equal 6. Okay, any questions? All right, let's take a look at another one. Now we're going to look at the probability that the sum is less than or equal to 9. So there's a lot of ways that it could be less than or equal to 9. And so instead of listing all of those, what would be the opposite of being less than or equal to 9? greater than 9, right? Yeah. So it's going to equal 1 minus the probability that the sum is greater than 9. So again, I'll make a little table for myself for my 2 dice. So if the sum is greater than 9, what are the possible sums it could be? It could add up to 10, it could add up to 11, or it could add up to 12. Can't go any higher than 12 though, right? Because 6 and 6 is the highest. Okay, so yeah, 6 and 6 would give us 12. How could I get 11? 6 and 5, or 5 and 6. And how could I get 10? 5 and 5. How else could I get 10? 6 and 4, or 4 and 6. All right, so now I've got 6 ways that it could be greater than 9. So it's going to equal 1 minus 6 out of 36, which is 1 minus 1/6. And so that equals 5/6. So the probability that the sum is less than or equal to 9 is 5 out of 6. All right, so here's a really easy one for you. There actually are problems this easy on your homework tonight. Find A bar, find the probability of A bar if the probability A is 0.45. What's it going to be? 0.55. Yes, you take 1 minus 0.45, and so it would be 0.55. Okay, I'm going to have you guys figure out, I've got 2 dice. What's the probability that the sum is not equal to 5? I'll let you guys figure this one out. Give you a second to do it. Okay, so you guys figured out that there were 4 ways that the sum could equal 5, and so 4 out of 36 reduces to 1/9, so 1 minus 1/9, and you get the probability that it's not equal to 5 is 8/9. All right, let's take a look at another question. All right, so for example 5, we've got a restaurant gives free fortune cookie to every guest. The restaurant claims there are 500 different messages hidden inside the fortune cookies. What is the probability that a group of 5 people receive at least 2 fortune cookies with the same message inside? So rather than figuring out the possibility of having 2 the same, 3 the same, 4 the same, 5 the same, if there aren't 2 of them the same, how many are the same? What's less than 2 of them the same? 1 the same? In other words, they're all different, right? None of them are the same. So the probability that we're going to have greater than or equal to 2 that are the same is going to be 1 minus none of them are the same. Because as soon as you don't have 2 the same, none of them are the same anymore, right? Right. Okay. All right. So if we're going to have them all different, none the same, for the first one, how many possible messages do I have? 500 possible messages. But if I'm not repeating, how many are left for the next one? 499. Then 498, and then 497 and 496. That's as far as I go because there are 5 people. So I'm only worried about the first 5 possibilities. Now, if I can repeat it, the total possible ways that I could have it is that I actually have 500 choices each time, right? If I'm not worried about repetition. So the top is the no repetition and the bottom is if I do have repetition. The top is none of them are the same out of all the possibilities. So go ahead and, well, we can reduce the 500s. In your calculators now, go ahead and multiply 499 times 498 times 497 times 496, and then divide it by 500 to the 4th power and see what you get. Go ahead and give it to me to 4 decimal places. All right, so we get 0.9801, and so if we subtract that, we find that the probability that at least 2 are the same is 0.0199. So not a real high likelihood that you would get 2 the same. Now, suppose that there are only 100 different messages. Now I want you guys to figure out what the probability would be if there were at least 2 the same. If there were only 100 different messages. There's still 5 people, yes. All right, so when you guys figure this out, you ended up with 1 minus 0.9035, and that gives you 0.0965. So almost a 10% chance that you would have a duplicate if there were only 100 different messages. Okay? Any questions? Yes. If they only had 6 different messages, you mean?
No, like
at least 6 the same. That's not possible because there's only 5 people. So I wouldn't ask you for if 6 of them were the same. If there were more than 5 people?
you're asking for 2 right now.
Okay. The reason I asked for 2 the same is because this is an instance where the complement makes more sense. If you're asking me what are the odds that all 5 of them are the same, then that's a whole lot different problem. I've got only one thing I'm trying to find. So it doesn't make sense to use the complement then. Because the complement to all 5 of them the same would be the probability that 4 of them was the same, and the probability of 3 of them being the same, and the probability of 2 of them being the same. So why would I do all of those and subtract it from 1? I would just find the probability that all 5 are the same, which would be 1 over 500 to the 5th power. I wouldn't go to the trouble of using a complement in that situation. Okay? Does that answer your question? Okay. That's it for today.